Hello, I'm Richard Bloor of Roden Schwartz. In this application video, we're going to discuss the decoding, triggering of low-speed serial signals using Roden Schwartz oscilloscopes. In the first instance, I'm going to use our performance oscilloscope, the RTO. In this case, the setup I have is I'm looking at a CAN signal from my first device under test. I've got an active probe connected to channel 1, and if I look into the scope display, there I can see the data transitions. If I press the single button, you can see the data packets coming through. And this is because we just free run triggering at the moment, and it's pseudo-random data. And in the past, with this type of signal, engineers have typically had to go into a zoom menu, isolate a frame, and then look at the individual transitions and count the zeros and ones and refer to a lookup table to determine what that frame related to, the data length code and so on. Now, over the years, application packages have been added into oscilloscopes to allow better efficiency for engineers, better use of their time, and to make the instruments more useful. If I go into the protocol menu, I can see here that I can configure the oscilloscope to trigger on many different protocols. So I can see I2C, SPI, UART, CAN, LIN, and FlexRay. And these are options that can be loaded into the instrument. And as we discussed, I'm looking at a CAN signal. So I'm going to select a CAN signal. I'll allow the data to run. And I want to decode this data. And I just have to go into the configuration and make a few changes. If I look at the data, where the data is coming from, you can see the flexibility I was talking of with this oscilloscope. Not only can I decode and trigger on the analog inputs, I can also look at math waveforms, reference waveforms, and also the digital channels if the appropriate option has been installed. In this case, I'm going to select channel 1. I'm going to select CAN high. The bit rate I know is 50K. Now, quite an important thing when you decoding the data is the threshold. The threshold determines whether the data has been decoded correctly or not. In the threshold setup, we have a soft button which automatically sets the threshold to 50%. And in the background, as soon as I press that button, we can then see the decoded data. I'm just going to stop the acquisition for a second and move the zoom window around a single frame. And there I can see the ID number, 314 hex, the data length code, the 3 packets of data that are associated with that code, the CRC, and in this case we have an error bit as well. So very simply, I've taken an analog input and I've automatically decoded that data, which in the past would have taken an engineer a significant amount of time just to count the bits. So that's quite interesting. I've got the decoded information. The next step I may want to do is to trigger on a specific event. Well, first of all, let's allow the scope to run. I'm going to slow down the time base, and then what I'm going to do is bring onto the display a decode table. So this decode table, if I stop the acquisition again, here I can see the frames, the number of frames I've captured, the state of them, the type, the ID, whether it's 29 bits or 11 bits. I can see the ID value in hex, the data length code, and so on. So I can scroll through this and see the information. And here I found something quite interesting. I can see 2 1E5s next to each other. So I'm going to choose to trigger on those. I'm just going to move the decode table to one side for a moment, and I'm going to bring the menu back. Now, the menu system in the RTO is very simple and straightforward, and each menu links to another menu that could be associated with the setup. So, for instance, the protocol menu has a tab where I can link nicely into the trigger setup. Now, the trigger, we have a digital trigger that's implemented in hardware, and this allows for a very, very fast update rate. Again, the setup is very simple. I start on the left-hand side, and first of all, I want to select my source. And again, you see the flexibility of the oscilloscope, triggering on any channel, including digital. I'm going to select serial bus, and I've decoded serial bus number 1. The protocol is CAN. I want to trigger on an identifier. The frame type is data, the ID type is 11 bits, and I want to trigger on 1E5. Enter. So now if I allow the scope to run, you can see I have a steady waveform now in my main acquisition window. And my zoom is positioned around the trigger, and here I can see a remote data frame 1E5 and a data frame 1E5. Now, it'd be quite interesting now, rather than just to see a hex value, see something that's more meaningful. For example, in CAN, many automotive engineers would prefer to see something associated with a component in the vehicle, for instance, the engine, the dashboard, a window. So if I go back to the protocol menu, we can import a label list, and that label list looks at the address type. So we were triggering on 1E5, and in this particular label list, the label, the symbolic name for 1E5 is engine data. So I'm going to go ahead and apply that list. And if I take this menu away and look into the display again, instead of seeing 1E5, I now see the label engine data. And now I'm going to move to our mid-range oscilloscope, the RTM. I'm just going to disconnect channel 1 and connect to the RTM channel 1. I've already set the oscilloscope up in the same way that I've set the RTO. I'm decoding the data, I'm triggering on an individual frame, and here in the zoom display you can see 1E5 and 1E5. But I want to analyze this waveform now in a little bit more detail. So I'm just going to stop that acquisition. I'm going to go into our search menu. And what I want to look for is errors in the acquired waveform. So if I go into the search menu, I can see that I can search for protocol. If I go into the setup, there is a number of different events that I can search from. Frames, errors, identifiers, ID and data, ID and error. But in this case, I just want to look for errors. I'm going to go into the error setup and select CRC, acknowledge, form and stuff bits. If I go backwards, and already in the display, I can see that the scope has analyzed the waveform, and I can see that there's 19 error events already shown. So I go back to the event menu. I want to view an event table, and I'm going to select track event. Now what the track event does is I select the individual events that have been found. It will automatically adjust the zoom window for me to be centered around the error. And if I just move the navigation wheel through the table, I can see the index, the time, and the event. I can see bit stuffing errors, missing acknowledge, CRC errors. And as I move the navigation through that table, you see the zoom window being repositioned at the appropriate point in time through the main acquisition window. Now at this point, I'm going to move, I'm going to move back to the RTO. Okay, so we've triggered and decoded and viewed an event table. As we talked about the flexibility, I'm also going to bring on now another channel. So just to make things a little simple, I'm going to clean up the display and I'm going to minimize the channel 1 waveform and the decoded data. Go into the vertical settings, and now I'm going to enable one of the digital channels. So I'm going to look at D0, and straight away I can see D0 is active. And D0 is connected through the logic probe onto my second device under test, where here I'm looking at an RS-232 signal. And again, in the same way, I can go to the protocol menu, go into the configuration, and this time I'm going to configure buzz number 2. I'm going to select RS-232. The source now is D0. I want to decode that. Again, I need to select the bit rate, in this case is 14.4, and as before, set the threshold. So there I see the data and the decoded information. Now, I may want to look at these simultaneously, and with the display settings for the RTO, I can bring in or minimize various waveforms and position them in the display in a place that feels comfortable and easy for me to view. So let's stop that acquisition. So now we've taken two different data types, we've decoded them, And to finish my work on this signal, I may want to save that information or the decoded information in a results format. So going back to the protocol menu, if I look at the display and I show the decode tables for both bus types and go to result export, and here I can choose which of those results tables that I'd like to export. In this case, I'm just going to export B1 and B2. Here I can select the delimiter and the file type and obviously save that to view at a later time and enter into my report. So in summary, the RTO and the RTM are both capable of triggering, decoding and analysing low-speed serial data. Thank you.